All right, today we are continuing on with exponential functions. We're going to go ahead and redo number 4 right here just to make sure everybody understands, because we were doing this pretty quickly yesterday towards the end of class. So there is what's called a compound interest formula. Does anybody have the compound interest formula on their paper already? Go ahead. Go ahead. A equals P, parentheses, 1 R over N to the power of NT. That's it, okay? Now, A is the final amount, all right? That's like the final amount that you get, all right? What does P represent, everybody? P represents the principal amount, and the principal amount is the initial amount of investment, all right? R represents the percentage or the rate, but what do we have to make sure we put it as? We have to put it as a decimal. So make sure you have to put it as a decimal. N equals the number of times it's compounded in a year, all right? Number of times it's compounded, and T represents your years, all right? So what are we starting out with? We're starting off with $1,000. What's the rate? The rate is 4%. So how do we write 4% as a decimal? 0.04. Just remember, whenever you take your percentage, if you want to change it to a decimal, just divide it by 100, and that gives you your whatever your decimal is. Or just move it over 2 decimal places to the left. All right? But here's just a little formula if you want to just have a formula so you don't have to think too much and you have a calculator. All right? Divided by N. Now, if it's compounded monthly, that means every single month. So our N value would be 12. And then we have to do 12 times the number of years, which is 5. So it's in the account for 5 years. So in our calculator, what we did is we opened up a parentheses. We typed in a 1,000. Oh, no, hold on. We did 1,000. And then we opened up the parentheses, my bad. I put 1 plus 0.04 divided by 12, and then I raised that to the power of 5 times 12, which is 60. Okay? All right? So, how much money, all right, would we have made if we left it in there for 5 years without doing anything? It just sits there. All right? So our answer would be 1,221. All right? 1,221. That's how much money would be in the account. Now, guys, we're going to do a little example problem here, okay? So let's say, for example, when you turned 18, okay? You turned 18, you got yourself an independent retirement account. And for the first 6 years, you just saved $2,000 a year. So the first 6 years, you just saved you're like, you know what? You're like, man, I'd like to take that $12,000, okay, and just let it sit, all right, in a mutual fund, all right? And so let's say the mutual fund earns a rate of, say, 9%, all right? But by the way, mutual funds usually compound quarterly, which that means 4 times a year, all right? And then we raise that to the power of, let's say you just let it sit there for 4 times a year, so we'll do 4 times a year. And let's say we let it sit there for how many years? How many years you guys want to keep it in there? 18 years? What? 20? Let's do 20? All right, let's do 20. Just sit there for 20 years. Without doing anything. That's how much money you would have at the end of 20 years without putting any more in. Okay? Well, what if you decided, you know what? You don't want it to be in there 20 years. You want to sit there for 25 years. Look at the difference between just 5 more years. Wow, extra 40 grand. You leave it in for an extra just 5 years, and suddenly it jumps up to 40. Well, what if we're like, you know what? Think about how old you're going to be, I don't know, 30 years from now. 30 years. Okay? Now, even more important than years is how much you're making. Okay? Now, in my mutual fund, I am averaging I'm averaging over a long period of time, I'm averaging about 12%. Not 9%. Myself, yeah. Okay? So, in 30 years, I would start with 12,000 without adding any more. What do I have in 30 years? 416,000. Now, this is without adding any more. But what do you think the best thing to do is? Just keep adding it every single month. Just add a little bit. Now, there's a different formula for that. We're not going to talk about that right now. But this is if you just let it ride. Okay? Just let it ride. Don't even look at it. Just like go to sleep and then wake up. All right? So, this is what's called what? Compound interest. Now, I don't know anything that's compounded monthly. Okay? Compounded monthly is more just for a math problem than it is real life. Real life is compounded quarterly. Okay? So right now, let's go ahead and look at number 5. See if you guys can set up number 5. All right? It says, suppose Jacob has a savings account with a balance of $1,400 at a 4% interest rate compounded monthly. If there are no other deposits or withdrawals, what will Jacob's account balance be in 3 years? Why don't you guys go ahead and set that up? See if you guys can set it up on your own. We'll see what you guys get. I'm going to pause the video right now. All right, so how would I set this guys up? What would I start with? What do you think? Help me out here. Come on now, somebody. 1,400, good. What do I do now? Parentheses. 0.04 over 12. We close that, right? And then we do to the power of what? 36. Now, why is it 36? Because it's a power of 12 times 3. So when we do that, I'm just going to scroll up right here. I'm going to grab that. Let's go ahead and edit it real quick. So right now, we basically start out with, how much did we start out with? 1,400. So I got to delete one of these zeros. Sorry, we don't have 14,000. All right. It'd be nice. Wouldn't it be, do you guys see the difference between, how about this? Let's do 12% because 12% is so much better than 4%. All right. So I do that divided by 12. Got to close that. And then up here, what do I have to make it? I got to delete that. I'm going to put a 36. Okay? Look how much you would have if we did it to the power of 36. Wouldn't you guys agree? That's a pretty good jump in 3 years. All right, just sitting there. But what really matters, more than anything, what matters? Your dadgum percentage rate. Okay? So where do you think banks and institutions that deal with debt, that's where it's compounded monthly. And where do they get you? They get you with the percentage rate. Do you guys know what the annual percentage rate, the average annual percentage rate for a credit card is? Do you think it's 4%? Do you think it's 12%? Do you know what it is? No, not that high. It's usually 26 to 30%. All right, 20. Now, there are credit cards that have 14, 15%, okay? They'll start out with the 12%, and all of a sudden you'll like see a bill, it's like all of a sudden it's like 17, 18, 19%. So this is always, if for credit cards, it's always way above like 4% or 12%. Okay? Just so you guys know. So that would be our answer right there. Okay? By the way, that's why it's important. If you ever get a credit card, always pay it off every single month. If you pay it off every single month, guess what? They can't charge you interest because it's paid off. That's what. All right? That's fine. You can use it for gas and everything as long as you what? Pay it off every single month. All right, guys, here we go. It says determine the growth rate. What? How do we determine the growth rate? So check this out. We have a formula, right? It says P of T equals 100 E, which is Euler's number, to the power of 0.271, and then we have T. Now, you guys need to understand what growth rate means. So check this out. This is in the form of A times B to the power of X. Now, what is our A value in this particular problem? What's the initial value? 100. All right, that's our 100. So we're starting out with 100 bacteria. So that's this answer. What's the initial number of bacteria? That's 100, okay? But this is what they don't give us. They actually don't give us the growth rate. They don't give us the B value. They say the B value is actually equal to E to the power of 0.271. So what you're going to have to do in your graphing calculator is you're literally going to have to do this. You're going to have to find the E. Now the E is you have to hit the second button and you got to use the division button, okay? And you actually have to raise that to 0.271 to actually find what's called the growth rate. Do you guys see this number, 1.311? That's our growth rate. So what I want you guys to do right now on your paper, right now, I want you guys to understand this equals this growth rate. So just do it to the nearest thousandth. So just cut it off right there. That's good enough. That's your growth rate for our problem. So determine the growth rate. The growth rate was approximately equal to 1.311. Does everybody understand that I had to do e to the power of 0.271 to actually find what was called the growth rate? This is something you're going to be doing in the Khan Academy. Sometimes it's going to ask you for the rate, and you have to do something, a number to a certain power. Okay? So here's what I'd like you to do. Find the number of bacteria in 5, 10, 24, and 72 hours, and then make sure you round your answer to the nearest whole number. So I want you guys to use, you can use the graphing calculator, all right? Think of it as x and y. Your x values are 5, 10, 24, and 72. I want you guys to see what happens when you guys find those answers. So I'm going to pause it, see if you guys can find the answers, and then we'll check your answers in just a second. All right, here's what we're going to do. We're going to go to the calculator, all right? You're going to hit y equals, and in your calculator, you're going to start out with 100, all right? Then you're going to hit second division to get the e. Then you got to raise that sucker to 0.271, but instead of the letter t, we're going to use the letter x. Now, this is going to be kind of interesting. Can you guys go second window, hit second window? Do you guys see where it says independent and it says auto? I want you to switch it from auto to ask. It's kind of helpful. So we're going to ask for the independent value. So check this out. Once I ask for it, are you asking for it? Yes, I'm asking for it. So watch this. Now I can type in a 5 and say, I want to know 5. What was another one I wanted to know? 10. I want to know 10. What was the other one? What was it? 24. 24. And what was the last one? 72. So that's kind of a cool feature in the graphing calculator. You get to ask it. So remember, how did I do that? Second window. I switch it from what? Auto to ask. And then you check your table. You actually get to ask for the number. So that's just kind of a cool thing you can do. Now Desmos, you just type it in and it's do the same thing. So right here, what's my answer going to be for this one? 300 and what? 88. That's the nearest whole number. What's this one? 1503. This one I'm just going to leave. Wow, these bacteria are growing fast. It's like a pandemic. Dun-dun-dun. Okay, and then this one, this is what? 3e to the power of 10. What does that mean? That means 3 times 10 to the power of 10. So basically you have a 3 and how many zeros behind it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, comma. 1, 2, 3, comma. 1, 2, 3, comma. That is a lot. Did I mess up? I'm not sure. I'm sorry? Oh, just that number. 66,781. Let me try that again. Ready? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Comma, comma, comma. That's a lot. That's a lot of zeros right there. Whew. That's a lot of bacteria, everybody. All right? I know it's getting out of control. All right, so that's how you guys can do that one. All right, I'm going to move down over here. Ooh, you have $1,000 to put in the bank. One bank offers 5.7% interest compounded monthly. Another bank offers 5.6% compounded continuously. Which would you choose to make the most money after 2 years or after 5 years? Okay, guys, here's what we're going to do. We're going to look at the compound continuously formula. Anybody see a compounding continuously formula anywhere? Woo, right there. Can you guys write PERT and then this one? This is your compound interest. This is your compound interest continuously. So we're going to go back up here. So take a look at that. We're going to write it down right here and take a look. So could you guys make a column real quick? Won't take long. We're going to compare. All right. So this is the was it monthly? So we're going to compare monthly to continuously. So this formula is A equals P e to the power of RT. And then this one was A equals P parentheses 1 plus R over N to the power of NT. Whew. There we go. Write those down. Be nice and easy. What do we start with no matter what? 1,000, right? So put 1,000. Don't worry about the A. Just know that whatever we get is going to be A, okay? Then this one we're going to put E. So put the letter E. Now what's our rate for the continuous? 5.6. So what you're going to have to do, guys, you have to put 0.056, and you're going to have to multiply it by 2. And then what are you going to do for the 5 years? You're going to do the exact same thing. I don't know if you guys can see it okay. I know I'm kind of writing kind of small. Then we got to multiply it by 5. So you could do parentheses if you want. So let's see how much money we get. So in your calculator, here's what you're going to do. 1,000. Second division, there's the E. We got to raise it to 0.056, and we're going to multiply it by 2. There's our answer for 2 years. There's our, go over here, change it to a 5. There's our answer for 5 years. So could you guys, right now, I'm going to leave it up there. That's your answer going to be for 2 years. This is for 5 years. What's going to happen to that 2? It's going to round up to a what? It's going to round up to a 3. So write those two answers down. All right. So we got 1118.51. All right. 1118.51. 1118.51. And what was the other one? 1323.13. I wish it would go back to where I was. What was it again, guys? What one was it? 1323.13. So this is after 2 years. This is after 5 years. That's how much money. Now, what does continuously mean? Like, just every single, like, it just keeps going over and over and over and over and over and over and over. Not just once a year, not just twice a year, it just keeps compounding over and over and over again. You like, what? How can it only be that much? Because everything has limits. You know what you're limited by? You're limited by your percentage rate. Okay? The percentage rate matters more than anything else. So check this out. Let's say, look at this. This is just, what percentage is it off? Just what? 0.1%. This is compounded monthly. So we got to do 1 plus. And what's our percentage rate? 0.057 over 12. And then we got to raise to the power of NT. So the number of times is 12. So after 2 years, we put times 2. And then we just do the exact same thing. I apologize for my handwriting. Hope you can see it's 0.057 over 12. And this time we're going to do 12 times 5. So we're going to go over here. 1,000, parentheses, 1 plus 0.057 divided by 12 to the power of 24, because 2 times 12 is 24. Interesting. Okay. So percentage rate really matters more than how many times it's compounded. Check it out. You see how much money? You made more money compounded only 12 times a year because it had a higher percentage rate than you had compounded continuously. Okay? Now, continuously will always beat 12 times a year if the percentage rate is the same. So I want you to kind of see that, okay? Do you see how this one continuously does beat 12 times a year just by a little tiny bit if the percentage rates are the same? But these are the answer to the other two, okay? So that's the answer to this one and this one. Now, this is all I'm going to do in this assignment. All right, so for those of you who are watching online, you don't have to do the other ones. We're going to be working on the Khan Academy, which is usually the same concept. Just remember that this is the main concept you guys need to understand, okay? In an exponential function, this is your A will always be your initial value. B will either be a growth or decay rate, and X will be your time over a period of time. So just remember this. This is your initial. This is going to be your growth or decay rate. All right? Just remember, if B is greater than 1, it's growth. If B is less than 1 but greater than 0, it's decay. So remember, that's going to be what's called a growth rate, and this is going to be a decay rate. And then we're going to be working on the Khan Academy and trying to test our abilities out there. Okay? So you have a good day, and we'll see you tomorrow.